Hello everyone. In this video, we will see the basics of organic chemistry. So let's first of all see what is organic chemistry. Actually, organic chemistry is a study of hydrocarbons and their derivatives. So what are hydrocarbons? Actually, hydrocarbons are those compounds which contain only hydrogen and carbon and no other element is present in them. While the derivatives, they can contain other elements as well. So let's see first of all hydrocarbons. So we have got many hydrocarbons made over here. And if you look at these hydrocarbons, first of all, the first thing that we need to know is that each carbon, it can make four bonds, okay, because it has four electrons in its outer shell. So carbon has ability to attach with other carbons to make chains like this. You can see two carbons attached together to make a bigger molecule. Even we have got a four carbon chain over here. Carbon also got the ability to make straight chains like this, or it can make the branched chain like this. You can see the three carbons over here, and there is a branch present with one carbon attached like this. So carbon has very unique abilities. Carbon can make single covalent bond with the other carbon. It can make a double covalent bond and even a triple covalent bond. Carbon can make open chain compound like this. Carbon can make closed chain compound like this. And we can have a closed chain compound with double bond as well. So we got a variety of compounds in carbon chemistry. So that's why organic compounds are huge in number because of all these qualities present in the carbon. These structures that I have made and the way in which they are made, what we have done that we have made all the atoms and all the bonds. When we draw any organic compound in this way, we call it that this is the displayed formula. So these are all the displayed formula that we have made. So this formula in which we got two carbons and there are six hydrogens, the way we have written this formula, we will call it as the displayed formula right now. Okay, but there are different ways to express the same chemical compound. For example, this compound, it can be represented as CH3 and CH3. When we write in this form, it is known as the structural formula. This compound, it can be represented in more simple way, in more compact way, and that is C2H6. So when you write it in this way, it is known as the molecular formula. So finally, we can make this formula even more simple by taking the simple ratio, that is CH3. So when you write in this way, it's called as the empirical formula. So for example, this compound, this formula that we have drawn is displaying all the atoms and all the bonds. It's called as a displayed formula. So we can write it like this we write H2C double bond CH2. This one is the structural one, or we can say C2H4 is the molecular one and CH2 is the empirical formula. So for the same compound, we can have displayed molecular, structural, and empirical formulas. Now let's move ahead and see what are derivatives. So actually derivatives, they are the derived ones. For example, this is a hydrocarbon and this hydrocarbon contains one carbon and four hydrogens. So what we can do is that if you remove one of the hydrogens, like here we remove one of the hydrogens and replace it with Cl. Now this will not be a hydrocarbon. It will be called as the derivative of the hydrocarbon. Okay. Similarly, we got this compound, this one, and what we do is that we remove one of the hydrogen and replace it with some other element like another group, like we got OH. So this is not a hydrocarbon now, this is a derivative. So derivatives are actually the derived ones that we are producing from the hydrocarbons. So there are many derivatives that we can have, and in the upcoming lessons we will see more derivatives and we'll work on hydrocarbons and derivatives both. So there are some organic compounds which are not considered as organic. Let's see them. So the first one are oxides of carbon, like we got carbon monoxide, carbon dioxide. These are carbon compounds, but they are not considered as organic. Next are carbonates. For example, we got sodium carbonate, Na2CO3. We got calcium carbonate, CaCO3. These compounds contain carbon but are not considered as organic. The next category is metal cyanides. So we can have like sodium cyanide, NaCN. We can have potassium cyanide, KCN. They are not considered as organic. The last one are carbides. That is like calcium carbide, CaC2. So these are the compounds which contain carbon, but they are not considered as organic. It's all because of their properties that do not resemble the normal organic compounds. Now let's move ahead and see what do you mean by homologous series. Organic compounds, they are huge in number, but their types are few. And these types of the compounds, you can say the different classes of compounds that we have made based upon their properties, based upon similarities in them. Each series of compounds which are closely resemble each other, that is known as homologous series. So look at this list of compounds in which you see that the first member contain one carbon and four hydrogens. There are two carbons and six hydrogens. An increasing number of carbons and hydrogens are present. So we got their structural displayed formulas. We got their displayed formulas. We got their structural formulas. We got their molecular formulas. All these and their names as well. If you look at the names, you see all the names they end with the same three letters, ane. Okay, ANE. So this is actually the homologous series of the compounds, what we call them as alkanes. Alkanes, what are the qualities of alkanes? All alkanes, they are first of all they are hydrocarbons. That means they contain carbon and hydrogen only. Then the second characteristic is that they contain carbon-carbon single covalent bond. Okay, so these are the two characteristics present in alkanes. So if you look at the two consecutive members, you see there is one carbon and there are two carbons over here. So the difference between the two compounds over here, it would be one carbon, and you see there are four hydrogens and there are six hydrogens. So there's a difference of two hydrogens. So two consecutive members, they differ by CH2 group. The same is the case with the next two. If you see the next two, you'll find the same difference, that is CH2. The next two also differ by CH2 group. So we can say in a homologous series, the two consecutive members, they differ by CH2 group. So the two consecutive members, they differ by CH2 group or MR of 14. Okay. Uh, in a homologous series, if you look at the formula, we got one carbon and four hydrogens. We got two carbons and six hydrogens. There is a relationship between the carbon and hydrogen. And what is that relationship? That if you have whatever number of carbons you have, like you got n carbons, and if you make it twice and then add 2, you get the hydrogen. That means we can represent it as CnH2n plus 2. Like in this case we got C3, so the twice of C3 is 6 and 6 plus 2 is 8. Here we got C4H10, C4, 4 2s are 8 plus 2 10. This formula that we have presented like this is known as the journal formula. So all members in a homologous series, they have the same journal formula. Okay, and if you see the structure, you see all of them, they are hydrocarbons and all of them, they have carbon-carbon single bond. Due to these similarities in their structure, they all have similar chemical properties. Chemical properties are identical because of the similarity in their structure. But as you as you can see, the compounds, as you move down, they're getting bigger in size and their molecular mass is increasing. Due to this reason, there is a gradual change in their physical properties. That is like melting point, boiling point, density, they all vary as you move down with increasing molecular mass. So we can say that their physical properties, they change gradually. So there is one more characteristic that is present in a homologous series of compounds, that is that they have same functional group. So these are the characteristics of a homologous series. What do you mean by functional group? We'll see in a while. Don't forget to remember these names. You see, whenever organic compound contain one carbon, its name always start with meth, and the two carbon always start with eth. Then we got prop and bute. So meth, eth, prop, bute, these are the prefixes that we use to represent the number of carbons, and the endings like ane, this represents the differences in their structures, in their bondings, and it depends upon the different functional group. Now let's move ahead and see what do you mean by functional group. So functional group is an atom. It can be a group of atoms, or it can be a multiple bonds that is responsible for the characteristic properties of an organic compound. So a functional group can be an atom. For example, we can have like a Cl atom, or you can have like Br atom. We can have group of atoms. For example, we got the OH group, the that we can get COOH group. Multiple bonds, it can be like C double bond C, it can be C triple bond C. So when one of these groups is present in an organic compound, due to these groups of atoms, the compound behaves differently from others. It has some specific properties. So uh, each group imparts some specific properties to the compound, and such an atom or group of atom or multiple bond is known as functional group. Let's see the list of functional groups. So here are few functional groups that we have to study. The first one is alkene with carbon-carbon double bond. For example, we got a compound with C double bond C, and there are two hydrogen attached on both sides, and this compound will be called as ethene, because eth is for two carbons and ene represents the alkenes. Next we got the alkynes, in which we got triple covalent bond. So there'll be one more hydrogen because carbon can make maximum four bonds. So this compound has a two carbon and its name ending at ine, so it will be ethyne. The next functional group is halogenoalkane, in which what we can do is that we can replace the hydrogen present in the alkanes with the halogen. Let's see. For example, we got the alkane CH4, in which there are present four hydrogens. So what we do is that you remove one of the hydrogen and put Cl over there. So this will become CH3Cl, and its name would be chloromethane. The next functional group is alcohol that contain OH. That means we can draw the compound like this, that we got the three hydrogens and replace the fourth hydrogen with OH. So that gives you another compound, and this is known as methanol. Okay, and ending with ol. Alcohols end with ol. Next we got the carboxylic acids. It contains C double bond OOH. So we can simply write it as COOH as well. So let's say we got the carbon in of alkane, and then we put carboxyl group over here, C double bond O and OH group like this. Now, this compound contains two carbons and there is carboxyl, and its name is ethanoic acid. So these are some functional groups. So till now, what we have seen, that we can have some prefixes and some suffixes to name the organic compounds. Let's see those prefixes. So the four prefixes that we have is, the whenever we got one carbon, the name starts with meth, two carbons eth, three prop, four bute, and then we got some suffixes. Let's see them as well. So these are the four suffixes. That carbon-carbon single bond is always end with ane, double bond end with ene, alcohol OH end with ol, and carboxyl group present ends with oic acid. So using these prefixes and suffixes, we can draw many structures of the organic compounds. Now let's practice drawing some structures. So let's look at this structure in which we got two carbons, and whenever we got two carbons, the name starts with eth, and since there is a double bond present, the name end with ene. So the name of this compound is ethene. So look at this compound. We see there are three carbons present in it, and this carbon is bonded with double bond, and then there's a single bond. So since there are present three carbons, the name will start with prop, and there is present double bond, the name will end with ene. So propene is the name of this compound. So look at the next structure in which we got three carbons and there is an OH group present. So three carbon name, it starts with prop, and since there is an OH group present, the name should end with ol, so it's called as propanol. Okay, propanol. And also we see that the OH group is attached on this carbon, that is carbon number 1 from this side, so we can call it as 1 propanol. We can have another propanol. Let's draw that structure as well. So look at this structure now in which we got the same three carbons, but the OH group is not attached to carbon number 1, rather it is attached on carbon number 2. So if you start numbering from this side, this carbon is carbon 1, it's carbon 2, so OH is present on carbon number 2, so we call it as 2-propanol. So the two compounds, the two alcohols. Now let's move ahead and see. Let's say if we have to draw a structure, like it is said to draw a structure of 2-butene. Now 2-butene means that but means there are four carbons, and ene means that there's a double bond. And where is double bond present? That is at position number 2. So let's draw this structure. We got four carbons. So first of all, make four carbons like this. And at carbon number 2, you can make carbon number 1 here, carbon number 2 here. So this is double bond you will make over here, and then the rest of the valencies will fulfill with the hydrogen, and draw four lines around each carbon. So take 1, 2, 3, 4 around this carbon, 1, 2, 3, and then there's a 4. There is 1, 2, 3, and 4. And now we'll complete the valencies with hydrogen. So this is the structure of 2-butene. Look at this compound in which we got four carbons, and there is present a carboxyl group. So you know carboxyl group, the name ends with oic acid, and there are four carbons, so it's butanoic acid. So these are the names and structures of few compounds. I hope that you have got all these concepts, the basics of organic chemistry that we have seen, and we'll continue the more organic chemistry in the next videos. Till then, goodbye.